Hey guys, in this video we're going to learn how to find lengths of segments using coordinates and segment addition. So the segment addition postulate states that if you have a point W that's in between f and x on a segment, then if you add the lengths of fw plus wx, that should equal the entire length of fx. So if we have our 2 points, here's our f, here's our x, and we draw a segment in between them, and throw in w somewhere in the middle. What this means is that if you take the length of FW plus the length of WX, that should equal and represent the entire length of F and X. So that's what the segment addition postulate does. So in example 1, we're going to find the length of DC. So then, using this segment addition postulate, we can see that ED is 2x plus 10, DC is x plus 14, and then this 12 means that the entire length of EC is that measurement, so it's 12. So using this segment addition postulate, if we take ED plus DC, that should equal the entire length of EC. So let's write that down. Okay, so now we substitute what we know. So ED is 2x plus 10. The length of DC is x plus 14. And then EC is the entire length of the segment, so we put 12 in for that. Okay, so we can combine like terms. We have 2x plus x, that gives us 3x. 10 plus 14, that gives us 24. And that should equal 12. So since we're solving for x, we're going to take the 24 and subtract it from both sides. So we get 3x equals negative 12. So in our final step, we're going to get the x all by itself, so we're going to divide both sides by 3. So we get x equals negative 4. So now many students will think that we're done with this problem, but we're not even answering the question. The question is to find the length of DC, not to find out what x is. So make sure you always answer the question. So to find the length of DC, well, we write down that DC is actually equal to x plus 14. And we just figured out what the value of x is right here. So then we substitute in the value of x into our problem of where DC is. So we can say DC is equal to negative 4 plus 14. DC is equal to 10. So then that's our length that example 1 wants us to find. In the second example, we know that points A, B, and C are collinear and are positioned in that order. So we have to find the length of BD if AB is x plus 11, CD is 10, BD is x plus 24, and AC is x plus 16. So even though it doesn't tell us to draw the diagram out, we're going to do that so that we can see what's going on. So here's A, B, C, D, all on one segment, so they're collinear. They're all on the same line. So then it tells us that AB is x plus 11, it tells us that CD is 10, it also tells us that BD is x plus 24 and AC is x plus 16. Okay, so then the only component that we're missing is BC, but we have a combination of BD being x plus 24 and CD to be 10, and we have AC to be x plus 16, and then AB to be x plus 11. So in this case, I'm just going to pick the length of AC, and if I take away a portion of AC, that'll give me the length of BC. So the specific length of a portion I'm taking away is the AB part. So if I take AC and subtract AB, that'll give me the length of BC. Okay, so let's set that up mathematically. So we have x plus 16 minus the quantity of x plus 11, that'll give me the length of BC. So then I'm going to have to distribute the negative to x and 11 to get negative x minus 11 equals BC. And it looks like my answer is going to give me, it's going to be a numerical answer, and I'm not going to have a variable expression, so the process of finding the length of BD is going to be a lot shorter, as if I were to get a variable expression, we'll have to do another step. So then our x's cancel out, so we're just left with 16 minus 11. That'll give us BC, and that's just going to be 5. So then using the segment addition postulate, we can take what we know as BC and add it to CD to get the length of BD. So then 5 plus 10 gives us the length of BD, so ultimately our answer is going to be 15 for the length of BD.